Good day, Grade 10. I am Sir Rainier, your teacher guide for Science 10, Quarter 2, Week 1 video module. I am here to help you understand your Week 1 self-learning module. Here are a few tips to help you understand and apply the most essential learning competencies. Set a conducive learning space. Seek assistance from your parents or guardians. Take down important concepts. List questions you would like to ask from your teacher and reflect and apply the concepts that you have learned. Here is the most essential learning competencies for Quarter 2, Week 1. Compare the relative wavelengths of the different forms of electromagnetic waves, S10-FE-2A-B47. Now, let us know the expectations and outcomes. 1. Define electromagnetic waves. 2. Trace the development of electromagnetic wave theory. 3. Describe the transmission and propagation of electromagnetic waves. And 4. Discuss the properties of EM waves. Now, let's move on to your pre-test. Please prepare your pen and paper for your answers. You will be answering 10 items and choose the best answer from the options. Are you ready? 1. In the electromagnetic wave, what is the direction of the propagation of the wave? A. Always to the right. B. Cannot be determined. C. Parallel to electric and magnetic field directions. D. Perpendicular to the electric and magnetic field directions. 2. Who discovered the relationship between magnetism and electricity that serves as the foundation for the theory of electromagnetism? A. Hans Christian Ørsted. B. James Clerk Maxwell. C. William Gilbert. D. George Simon Ohm. 3. What mode of propagation of the electromagnetic wave that is useful in the frequency range of 2 to 30 MHz and for long distance communication? A. Ground wave propagation. B. Sky wave propagation. C. Space wave propagation. D. Tropospheric wave propagation. 4. Which of the following forms of electromagnetic waves has the widest frequency range? A. Microwave. B. Radio waves. C. Ultraviolet. D. X-ray. 5. What is the speed of electromagnetic wave in a vacuum? A. 0. B. Always the same as the speed of light. C. Changing depending on the value of its wavelength. D. None of the above. 6. Who showed the experimental evidence of electromagnetic waves and their link to light? A. Andre Marie Ampere. B. Heinrich Hertz. C. James Clerk Maxwell. D. Michael Faraday. 7. Which type of wave has the shortest wavelength? A. Gamma ray. B. Microwave. C. Ultraviolet. D. X-ray. 8. What type of waves are electromagnetic waves? A. Electric waves. B. Longitudinal waves. C. Mechanical waves. D. Transverse waves. 9. Which physical law governs the relationship between electric and magnetic field? A. Arithmetic equations. B. Einstein's equation. C. Kirchhoff's equation. D. Maxwell's equation. 10. Which of the following is not a characteristic of electromagnetic waves? A. Transverse waves. B. Need a medium to propagate. C. Travel at the speed of light. D. Has an extensive range of waves. Answer the same pretest questions in this Google form to know your score. Click the link found on the description area of this video module. Looking back, let us review some terminologies related to this week's video module. Grade 10, You are now seeing the parts of a wave. Crest, the section of the wave that rises above the undisturbed position. Trough, the section of the wave that lies below the undisturbed position. Amplitude, the distance from the undisturbed position of the medium to the top of the crest, or from the undisturbed position of the medium to the bottom of the trough. Wavelength, the distance between two adjacent corresponding locations of the wave train. The wavelength can be measured in one of three ways: crest to next crest, trough to next trough, or from the start of a wave cycle to the next starting point. Transverse wave is a wave in which particles of the medium move in the direction perpendicular to the direction that the wave moves. Longitudinal wave is a wave in which particles of the medium move in the direction parallel to the direction that the wave moves. Now, let me introduce the topic for this week 1, electromagnetic waves. Electromagnetic waves, or EM waves, are waves that are created as a result of vibrations between an electric field and a magnetic field. Properties of electromagnetic waves. Electromagnetic waves, or EM waves, are all the transverse wave that propagates outward from a source perpendicular to the direction of the wave's travel. The creation of all EM waves begins with an oscillating charged particle, which creates an oscillating electric field and magnetic fields. EM waves travel in free space at the speed of 3 times 10 to the 8 meter per second, and that is 300 million meters per second. EM waves possess different velocity of propagation in a different medium. When traveling between media, the wavelength changes, and therefore the speed of EM wave also changes. Also, this change is different for different frequencies. At this juncture, I will be discussing the development of electromagnetic wave theory. The following are the scientists who gave contribution to the development of the wave theory. Hans Christian Ørsted, a Danish physicist and chemist who discovered that the electric current in a wire can deflect a magnetized compass needle, a phenomenon that the importance of which was rapidly recognized and which inspired the development of electromagnetic theory. Michael Faraday. He was probably best known for his discovery of electromagnetic induction. The changing magnetic and electric fields are perpendicular to each other and to their direction of propagation. Therefore, they are seen as transverse waves. James Clerk Maxwell, an English scientist who developed a scientific theory to better explain electromagnetic waves. He described how electric charges and electric currents act as sources of electric and magnetic fields that form the basis of the electrical field of science and technology. Heinrich Hertz, a German physicist who applied Maxwell's theory to the production and reception of radio waves. He was able to perform many experiments that help explain reflection, refraction, polarization, interference, and velocity of electric waves. The Hertz is the SI unit of frequency that is named after him. André-Marie Ampère made the revolutionary discovery that the wire carrying electric current can attract or repel another wire next to it, and that's also carrying electric current. Wilhelm Gilbert. He discovered that the Earth was magnetic and theorized that electricity and magnetism are not the same. The Gilbert, a unit of magnetic potential, was named after him. Wilhelm Edward Weber. He discovered that the ratio of electrostatic to electromagnetic units equals to the value of the speed of light, leading to the conjecture that light is an electromagnetic wave. The Weber, named after him, is the SI unit of magnetic flux. Charles Augustin de Coulomb. He developed Coulomb's law, which defined the electrostatic force of attraction and repulsion. The Coulomb is the SI unit of charge, was named after him. Albert Einstein. He formulated the concept of the photoelectric effect. He was a German-born theoretical physicist who developed the theory of relativity, one of the two pillars of modern physics. And now, we are going to discuss the 7 types of electromagnetic waves in an electromagnetic spectrum. Radio waves. Radio waves have the longest wavelength in the electromagnetic spectrum. They are produced by making electrons vibrate in an antenna. They are used to transmit sound and picture information over long distances, and they are used to broadcast radio and television. Microwaves. Microwaves have smaller wavelengths than radio waves. They are used in satellite communications, radar, television, transmission, and cooking. Infrared radiation. It lies beyond the red end of the visible light. It is emitted by all objects. Our bodies radiate infrared, and under the red camera or a night vision goggle, our images appear in a variety of colors. Light is the only electromagnetic wave that can be perceived by our eyes. Hence, it's obviously the most important for you to observe the things around you. The greatest source of light on Earth comes from the sun. Visible light makes things able to be seen. Further increase in temperature and energy of a body compared to the shortest wavelength of visible light falls under the category of ultraviolet or UV radiation. This electromagnetic wave is produced by very hot objects aside from the visible spectrum they emit, like the sun. X-rays are a more energetic region of the electromagnetic spectrum. This EM wave is discovered by Wilhelm Röntgen. X-rays have shorter wavelength but carry higher energy than UV. They are used to view inside bodies and objects. The last portion, but definitely not the least, in the EM spectrum are the gamma rays. They have the shortest wavelength but the highest frequency and energy of all electromagnetic waves. They are used in medicine for killing cancer cells through the process of radiotherapy. The transmission and propagation of electromagnetic energy. 1. Ground wave propagation. It is also known as the surface wave propagation. It is a method of radio frequency propagation that uses the area of the Earth and the ionosphere for transmission that can propagate at frequency below 3 MHz. Number 2. Skywave propagation. It is also known as the ionosphere wave propagation. It refers to the radio wave propagation via the ionosphere. This happens when electromagnetic waves travel towards the sky after propagation and reflect the Earth from the ionosphere. Number 3. Space wave propagation. It is also known as the tropospheric wave propagation. It can travel directly or after reflecting from the Earth's surface to the troposphere surface, from the transmitter antenna to the receiver antenna. This is utilized in television and radar communication. Check your understanding. Instructions. Read each statement and identify if the statement is true or false. 1. Electromagnetic waves travel in a transverse form. 2. Electromagnetic waves are transverse waves only. 3. Electromagnetic waves do not require any medium for propagation. 4. Electromagnetic waves are not deflected by electric or magnetic fields. 5. Electromagnetic waves travel with a constant velocity of 3 times 10 to the 8 meter per second in a vacuum. 6. Electromagnetic waves transfer energy from the source of the waves to an absorber. 7. Electromagnetic waves are propagated by electric and magnetic fields oscillating at right angles to each other. 8. Electromagnetic waves have an extensive range of waves that differ in the frequency and the wavelengths called the electromagnetic spectrum. 9. Electromagnetic waves transfer energy through a vacuum. And number 10, a wave is a disturbance that transfers energy. Answer the same check your understanding questions in this Google form to know your score. Kindly visit the link below found on the description area of this video module. Post-test. Number 1. Which electromagnetic wave has the highest frequency than others? A. Microwaves. B. Radio waves. C. UV radiation. D. Visible light. Radio wave is a blank in wavelength than the gamma ray. A. Higher. B. Longer. C. Lower. D. Smaller. 3. He is probably best known for his discovery of electromagnetic induction. A. André Marie Ampere. B. Hans Christian Ørsted. C. Michael Faraday. D. Heinrich Hertz. 4. Electromagnetic waves are blank waves. A. Propagating. B. Transverse. C. Longitudinal. D. Oscillating. 5. This is utilized in television and radar communications. A. Space wave propagation. B. Skywave propagation. C. Ground wave propagation. D. Surface wave propagation. Number 6. This electromagnetic wave is produced by very hot objects aside from the visible spectrum they emit, like the sun. A. Radio waves. B. Gamma rays. C. Ultraviolet radiation. D. Visible light. 7. Which of the following modes of propagation of electromagnetic waves can be used for one-way communication from the military to submerged submarines as they penetrate to a significant depth in seawater? A. Space wave propagation. B. Skywave propagation. C. Ground wave propagation. D. Surface wave propagation. 8th, he discovered that an electric field that flows through a wire creates a circular magnetic field. A. Hans Christian Ørsted. B. Wilhelm Edward Weber. C. James Clerk Maxwell. D. Albert Einstein. 9. He was able to perform many experiments that help explain reflection, refraction, polarization, interference, and velocity of electric waves. A. Charles Augustin de Coulomb. B. Hans Christian Ørsted. C. Heinrich Hertz. D. Michael Faraday. 10. Which of the following is the speed of light? A. 3 times 10 to the 6 meter per second. B. 3 times 10 to the 7 meter per second. C. 3 times 10 to the 8 meter per second. D. 3 times 10 to the 9 meter per second. Answer the same post-test questions in this Google form to know your score. Visit the link below. Thank you and congratulations! You have completed your Science 10 Quarter 2 Week 1 video module. You may watch this video once again if you want to go back to the previous topics or lessons. Again, please subscribe to my YouTube channel for the next Science 10 Quarter 2 video modules. Thank you and God bless us all.